Hey guys, so in today's video we'll be going over Unit 1.11 of the Math AAHL course. And yeah, this is an HL only topic, so if you're SL you don't need to know this. But anyways, partial fractions, what are they? Now let's say we had this here, we had 4 over x minus 2 plus, let's say, 3 over x plus 1, right? Let's move this down a bit actually. Now, how do we combine them into one big fraction? The way we do this is we'd multiply the bottom by x plus 1, multiply here by x minus 2. So that way the denominators of both would be the same. And whatever we do to the bottom, we must also do to the top, right? So here we multiply by x plus 1, and here we multiply by x minus 2. And what we'd have there is 4 multiplied by x plus 1, plus 3 multiplied by x minus 2 over x plus 1, x minus 2, right? And we can expand, so we'd have 4x plus 4 plus 3x minus 6 over x squared minus x minus 2, right? So this here equals to, we combine the terms, so we'd have 7x minus 2 over x squared minus x minus 2, right? So what we just did is we combined these two fractions into one big fraction. Now, what partial fractions is basically removing all of this and starting from here and taking this big fraction and breaking it down into smaller fractions. So it's basically just going backwards from what we just did. So how do we do this? How do we go about doing this? Now, the first step is factorizing the denominator, okay? So factorizing this number in the bottom into linear functions. So linear means x to the power of 1, right? So how do we factorize this here? So we have x squared minus x minus 2. Let's factorize this. So equals to, equals to. Now we can use the quadratic method, or we can just factorize normally, and we'd get it as x minus 2, x plus 1, right? Which, if you remember, were the bases that we used before. So now we have it factorized. What we'd do is this here, our original fraction, we can write it as the sum of two fractions, right? So two fractions. And the denominator of these two fractions are the factors of the original fraction. So this would be x minus 2, and this would be x plus 1, right? And what do we put at the top? Well, for now, we'll just put a and b. And what we're trying to do is find out what a and b is. So let's move this a bit up. Step number 2 is finding out what a and b are, right? And how do we do this? Now, first of all, let's combine it into one fraction again. So we'll have 7x minus 2 over x squared minus x minus 2 equals to a multiplied by x plus 1 plus b multiplied by x minus 2 over x plus 1 x minus 2, right? So we just multiply both sides, or up and down, by this, and multiply up and down by this. And since they both have the same denominator, we can kind of just ignore it for now, cancel them out. And what we have now is this, 7x minus 2 equals this. And there's many ways to solve this from here, and I'm just going to go over the method which I usually use. So the first thing is expanding. So 7x minus 2 equals ax plus a plus bx minus 2b, right? So you just expand. And what we have next is basically, so these are all constants, right? There's no x's. And what we can say is that this constant plus this constant equals minus 2. And this x plus this x equals 7x, right? So the way you'd write this is our x naught, or our zero constant, would be minus 2, right? Our constant is minus 2, equals this constant, so a, plus the other constant, which is minus 2b. So this wouldn't actually be plus, it'd be minus 2b. Okay, so this is our x naught term. And now we do it for x1, which is x to the power of 1. So how here we have 7x, ax, bx. So 7x equals ax plus bx. And since they all have an x, we can kind of just divide everything by x, and the x's would go away. Just have 7 equals a plus b. And what we have now is systems of equations, right? So we can multiply this by minus 1, and we would have minus 7 equals minus a minus b, right? And now we add this and this together. We add them together, and I'll do this here. And what we have now is minus 9 equals minus a plus a is 0, minus 2b minus b is minus 3b. Divide both sides by minus 3, and we have b equals 3. So this b here, we know now, is 3, right? And how do we find a now? Well, we just substitute b equals 3 into this equation, okay? Or the other one. Actually, let's do the other one because it's nicer. So we'll have 7 equals a plus b, where b is 3. So a is 4, right? So a is 4. And this is how I would do partial fractions. There's other methods to do it. This is the method that works best for me. So yeah, this is how you would take a big fraction and split it into smaller fractions. And the reason why this is really useful is because when we get to calculus and integration, it is hard to integrate really big fractions. So we do partial fractions to split them up and make it a lot easier. And now before we move on, I just want to look at this extract from the syllabus guide for partial fractions. And if you notice, it says maximum of 2 distinct linear terms in the denominator. So the biggest or the most you'll be asked for in the IB exams is 2 distinct linear terms. Now the key part is distinct. It doesn't say 2 linear terms, it means 2 distinct linear terms. This means you can have 2 distinct terms, but one of them is repeated like 10 times, right? It probably wouldn't happen, but it is a possibility. So we'll go over what to do with repeated terms in the denominator next. And now we'll go over what to do if we had repeated factors in the denominator, right? So let's say we had 3x plus 1 over, and let's say x cubed minus 3x plus 2, right? And let's say we wanted to put this as a sum of partial fractions. How do we do this? Now, as we said, step 1 is to factorize. So we have to factorize x cubed minus 3x plus 2. And if you don't know how to do this, you can watch Unit 2.12 polynomials, but we essentially just use the factor theorem and then long division to put this in product of factors. And since this takes a long time, I'll just put the factors on now. But if you don't know how to do this, do watch Unit 2.12. But anyways, our factors would be x plus 2, x minus 1, and x minus 1, right? And what you notice now is that this x minus 1 is repeated. So we have 2 distinct roots, but one of the distinct roots is repeated. So what we can say is that this is basically 3x plus 1 over x plus 2, x minus 1 squared, right? So how do we put this in partial fractions? Now, what we would do, or how we would write this, is basically a over x plus 2, so what we did before, right? And what we do next is this thing called building up the powers. And what do I mean by this is we add plus b over x minus 2, or x minus 1, plus c over x minus 1 squared. Okay, so what you'll notice is I didn't just put this, I put another one in the middle, right? And what I mean by building up the powers is that if this here was like 4, so if it was repeated 4 times, we'd add plus d over x minus 1 to the power of 3, plus e over x minus 1 to the power of 4, and if it was to the power of 10, we keep going to the power of 10, right? We'd keep adding and increasing this 1 each time. For now, we'll just put to the power of 2. Okay, and the reason why we do this building up of powers, basically, we don't really need to know the reason, so I won't really cover it in this video. If you are curious, I will put a link to a video which I think explains it really well, but it is a bit time consuming to explain, and I don't want this video to go on for too long, so I just won't include it here. But again, if you're curious for why we build up the powers, do go watch the video in the link. If not, just know that we build the powers based on what this is. So since it's squared, we just have one normal, one linear, and then squared. Okay, that's all you need to know. Anyways, what we do next is what you do for any linear, what you do for normal partial fractions, which is make the denominator the same. So this a here has to be multiplied by x minus 1, x minus 1, b multiplied by x plus 2, x minus 1, and the c multiplied by x plus 2, right? So I have to make the denominators the same. And what we'd have is 3x plus 1 is basically a multiplied by x minus 1 squared plus b multiplied by x plus 2, x minus 1, plus c multiplied by x plus 2, right? So the method I used last time, you could do it now, but you'd end up with three-way systems of equations and it'll be way too time consuming. So I'll go over another method which you can use to find a and c, okay? And I'll tell you why a and c specifically. And this method is substitution. So let x equal a number. And let's say, what number do you want x to be? Well, we want these factors here to equal 0. So you want x minus 1 to equal 0 or x plus 2 to equal 0. For x minus 1 to be 0, we need x to be 1, right? So let x equal 1. And we put x equal 1, so we have 3 multiplied by 1 plus 1 equal a multiplied by 1 minus 1 would be 0, plus b, 1 plus 2 is 3, 1 minus 1 is 0, plus c multiplied by 3, right? And what we have left is 3 plus 1 equal 3 times c. 4 equals 3 times c. And now we have c equals 3 over 4, right? So that's how we would, sorry, not 3 over 4, 4 over 3. So that's how we'd find c. And we can go here and we can just put c as 4 over 3, right? So to find a, we'd do the same thing, but instead of letting it equal 1 this time, we want these two to go away. And to do that, we let x equals 2, or minus 2, sorry. So let x equals minus 2. And if we do that, we have 3 multiplied by minus 2 plus 1 equals to a minus 2 minus 1 would be minus 3 squared plus b. Minus 2 plus 2 is obviously 0, and this would be minus 3, but it doesn't matter anyways, and this would be 0. So what we have is minus 6 plus 1 equals a multiplied by minus 3 squared, which would be 9 anyways, right? So 9 times a. And we just simplify, so this becomes minus 5 equals 9 times a, and a equals minus 5 over 9, right? A equals minus 5 over 9. And we can just put this up here. So this here is a 5, this is a minus, and we put a 9 before. Okay, let's move this a bit to the side. So yeah, this is what we have so far. Now, how do we find b? Because we can't make this, we can't use the method we just used, because if this becomes 0, this goes away. If this becomes 0, this goes away. So what can we do here? What we do is we go back to the very first thing we did, or the method we used in the very first time. And this is the systems of equations one. So let's first expand the brackets. So we have 3x plus 1 equals a. Expand this, becomes x squared minus 2x plus 1 plus b. Expand this, becomes x squared plus x minus 2 plus c, this x plus 2. However, we don't need to take all of these, right? We don't need everything. All we need is to choose one term. And what I'm going to choose is I'm going to choose the x term. So I'm going to choose this term, this term, this term, and this term. It's just x1, right? And here we have 3x, so we just put 3 equals minus 2a plus b plus c, right? And what we can do next is we already know what a is, we already know what c is, so we just put in the values. So we have 3 equals minus 2, a we said is minus 5/9, plus b plus c, which we said is 4/3. So we have 3 equals minus 2 times minus 5 is 10/9, plus 4/3. We'll multiply top and bottom by 3, so we'll have 12/9, plus b, right? And what we have now is I don't want to erase, so I'll just put it up here. So we'll have 3 equals 22/9 plus b. Multiply everything by 9, so we have 27 equals 22 plus 9b. And subtract 22 from each side, so we'll have 5 equals 9b. And finally, we have b equals 9/5, right? Or not 9/5, my bad, 5/9. So b here is 5/9, right? Plus 9. And this is how we would take a fraction with repeated roots or repeated factors and put it as a sum of partial fractions. Now again, if this was to the power of 4, you'd keep adding 3 plus 4 and so on and so forth, building up the roots. If you want to know why, you can watch the video I'm going to put in the description. Alright, so to finish off this video, we'll just do this past paper question real quick, and it is a pretty simple one. Now, first things first, as we said, first step is to factorize the bottom. So we have to factorize x squared minus 3x plus 2. Thing is, we don't even need to factorize because we're already given the roots, right? So if x cannot be 1, this means that the factor is x minus 1, right? And if x can be 2, then the other factor is x minus 2. So we're already given the factors, kind of. So we just need to take these and apply them. So we have f of x is basically 4x minus 5 over, we said x minus 1, x minus 2. And if we put this as partial fractions, we'll have a over x minus 1 plus b over x minus 2, right? And here we just make the denominator the same. So we multiply by x minus 1, multiply by x minus 1, and same with the other, but with x minus 2. So we'll have 4x minus 5 equals a multiplied by x minus 2 plus b multiplied by x minus 1, right? And what we can do next is we can expand, right? Yeah, we can expand. So we have 4x minus 5 equals ax minus 2a plus bx minus b, right? And what we want to do next is we want to use the method I showed in the start of the video, where x naught and x1. So x naught would be our minus 5, our minus 2a, and our minus b. So we have minus 5 equals minus 2a minus b. And for x1, we'll have 4, or 4x equals a plus b, right? And you can already start the systems of equations straight away because these will cancel out. And what we will have is minus 1 equals minus a. Hence, or therefore, a equals 1, right? So a equals 1. And substituting a equals 1 into this equation, we have, do it here. So we have 4 equals 1 plus b, and therefore b equals 3. And the question is asking us to express it in partial fractions, so let's put it as partial fractions. So we'll have f of x equals, we said a is 1 over x minus 1 plus, we said b is 3 over x minus 2. And it is a pretty easy question. And I doubt you're going to be asked questions like this, but you're probably going to need to use partial fractions in calculus to simplify the integral and solve it. But yeah, don't expect to see partial fraction questions on themselves.